All right, so the next thing we're doing with logs is base E in natural logs. So E is now a variable that's going to have a specific value, and E is an irrational number with an approximate value of 2.71828. And then because it's irrational, it's just going to continue on and on forever. Right. And then E often occurs as the base of exponential and logarithmic functions that describe real-world scenarios. So if we're talking about the whole virus situation happening right now, I'm sure the exponential function that models the spread of the virus involves an E somewhere. All right. So base E exponential functions. An exponential function with the base E are called natural base. And the example of that, or the parent function of that, is f of x equals e to the x power. Right? And then base E logarithmic functions are called natural logarithms. So it would look like f of x equals log base e of x. But instead of writing log base e all of the time, there is a abbreviated version, and it's just f of x equals ln of x, and we read this as f of x equals the natural log of x. Right? And now from here, we're going to kind of split these notes up into two videos. So we're going to do the front page as one video, and then we'll do the back with solving as another video. So to convert between the two forms, so we have e to the x equals 24. Okay, so we start it just like we would with any other exponential function changing to a log. So you do the circle. So we do this. So we have log base e of x equals, nope, have that backwards. Log base e of 24 equals x. And then we said log base e can be abbreviated, so it's just going to become the natural log 24 equals x. All right. So for 2, draw your arrows. So we now have log base e of x equals 9. Change the log base e, so it's natural log of x equals 9. And then the next one we have log base e of 72 equals x plus 5. And then change this, so it's natural log of 72 equals x plus 5. All right, and then when we get to the back, we'll talk about how you can solve these so that we solve for x. All right, so now changing this from logarithmic form to exponential form. Because this is a natural log, remember the base is e, so if you want, you can put a little e here. And then once again, we just follow our circle pattern. So e is our base, 58 is our exponent, and then equals x. All right, so put your e in here, draw on your arrows. So e to the x power equals 6. And then put your e in here. So e to the 32nd. So e to the 32nd power equals x minus 9. All right, so that's converting between the two forms. Now, because natural logs are just this, it's a type of logarithm, we can use the same properties to condense and expand them. So for 7 through 9, we're just going to condense each expression into a single logarithm. So because it's natural log of 3 plus the natural log of 16, addition means we're going to multiply these two numbers. So we have the natural log of 3 times 16, and 3 times 16 is 48. So we have the natural log of 48. All right. So we have the natural log of 63 minus 2 times the natural log of 3. So the 2 in front of this natural log, remember, becomes the exponent with 3. So we have the natural log of 63 minus the natural log of 3 squared. So we can simplify the 3 squared. So we have the natural log of 63 minus the natural log of 9. And now we're using the quotient property. So because we're subtracting the 2, we're going to divide 63 and 9. So we have the natural log, and 63 divided by 9 is 7. So it's natural log of 7. All right, so we have 1/3 times the natural log of 64 plus 2 times the natural log of x. So we're going to move our exponents to where they go. So we have the natural log of 64 to the 1/3 plus the natural log of x squared. All right, so once again, this 1/3 as an exponent pops up, and just as a reminder, because we haven't talked about it a whole bunch, 1/3 as an exponent is the cube root. So the cube root of 64 is the natural log of 4 plus the natural log of x squared. And because we have addition between our two natural logs, we multiply these. So our answer is the natural log of 4x squared. And that's our answer for that one. All right, so now we're going to expand 10, 11, and 12. So we have the natural log of 5 times x. And since 5 and x are only factors, we're just going to split it up into the natural log of 5 plus the natural log of x. All right, and then 11, we have this squared outside this parentheses. So the squared is the first thing in our answer, so it becomes 2 as a coefficient outside our parentheses. And because we have a cubed divided by b, the division becomes subtraction. So we have the natural log of a cubed minus the natural log of b. And then this exponent goes in front, so we have 2 times 3 natural log of a minus the natural log of b. And that's our final answer. We've extended everything as far as it'll go. All right, so for 12, we have the natural log of the cube root of m squared n. We're going to change this cube root so that it is an exponent. So we have the natural log of m cubed n, or m squared n, sorry. And the cube root, remember, is the fraction 1/3 as an exponent. So we're going to put 1/3 there. And now it's just like this one over here. This 1/3 becomes the coefficient in front of our parentheses. So we have 1/3. And then we're multiplying now between the m and the n. So we have the natural log of m squared plus the natural log of n, which kind of gets redundant here, but it's fine. And now this squared is going to go in front of the natural log here. So we have 1/3 times the quantity 2 times the natural log of m plus the natural log of n. And that's where we're going to stop for this video. All right.